The topic of this video is finding the horizontal or oblique asymptote of a rational function. We actually have three problems for this video. The instructions say, find the horizontal or oblique asymptote, if any, of, and we have three functions here. Alright, so we notice that for each function, it is a rational function, which means it has a numerator and denominator that are both polynomials. The steps for determining the horizontal or oblique asymptote of a rational function are to determine the degree of the numerator polynomial and the degree of the denominator polynomial, and to compare them. And then based on that comparison, take one of four different actions. So let's determine the degree of each polynomial. Let's begin with this 3x. There's a hidden exponent of 1, and since that is the largest exponent of x, this is degree 1. As a reminder, when a polynomial is in standard form, it is the highest exponent of x that determines its degree. In the denominator, this is x to the first power plus 13x to the 0 power, so the largest x is also 1. This is degree 1. Okay, next. 3 and 4 are the exponents that tell us the degrees. So the numerator has degree 3, the denominator has degree 4, and for our last rational function, we've got 4 and 2. The numerator is degree 4, the denominator is degree 2. Okay, now we're ready for the comparison step. So, first we're going to compare for r of x. We see the degree is the same for the numerator as well as the denominator. So I'm going to write n equals d, numerator equals denominator. This is case B in the 4 cases that we learned about in an earlier video. Let's read it. If the degree of the numerator and denominator polynomials is the same, then the horizontal asymptote is y equals b, where b is the ratio of the highest degree term coefficients. So let's go ahead and write that we know that we have a horizontal asymptote. We know that its equation will be y equals b, and we just have to determine the value of b. So we look at the terms that gave us the degree of 1 for the numerator and the denominator, which would be this term and this term. And specifically, we look at the coefficients of those terms. This has a coefficient of 3. This has a hidden coefficient of 1. We need to divide them. 3 divided by 1 will tell me the value of b. So this b is equal to 3 divided by 1, which is 3. So the horizontal asymptote is y equals b, but we found that b is 3, so we get horizontal asymptote y equals 3. All right, let's move on to our next function, t of x. Here we see that the degree of the numerator is less than the degree of the denominator. This is case A from our 4 cases. Case A says, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0, also known as the x-axis. Okay, let's document that. So we get the horizontal asymptote, y equals 0. All right, g of x. Here we see that the degree of the numerator, 4, is bigger than the degree of the denominator. We must always ask ourselves, by how much? In this case, it is bigger by 2. Therefore, we are dealing with case D. Let's read case D together. If the degree of the numerator polynomial is 2 or more degrees higher than the denominator polynomial, there is no horizontal or oblique asymptote. So we can document this as our answer. No horizontal or oblique asymptote. And with that, we have completed all three of these problems.